everyone. I would like to take a few minutes to provide you with a closer look at the Next Generation Science Standards, or NGSS, practice number 2, developing and using models. In the fall of 2013, California adopted the Next Generation Science Standards, and now science teachers can begin to unpack the performance expectations and skill sets needed to create 21st century ready students. This short introduction to instructional modeling will focus on 3 questions. What is the purpose of modeling in science? What are the types of science modeling? And how can we increase the rigor in science modeling? All science teachers incorporate modeling as a way to engage students with complex information. A simple example of a model could be a diagram, sketch, or drawing. This could be created as a prediction or as a check for understanding. Physical realia, or using items from the real world to model scientific understanding, can also be considered modeling. Mathematical representations built from data is another way teachers could incorporate modeling. Students could analyze the relationship of adenine and thymine to cytosine and guanine in a variety of organisms to construct a model to explain DNA-based pairing. Creating analogy statements like the mitochondria of the cell is similar to a power plant because both create energy is another way to expose students to modeling. Lastly, computer simulations where students can manipulate independent and dependent factors is a form of modeling that incorporates technology. Appendix F of the Next Generation Science Standards provides valuable information on how teachers should use modeling as a scientific practice with students. According to the NGSS, models are used for different purposes depending if you are teaching science or engineering. In science, models are used to represent a system, aid in the development of questions and explanations, generate data to create predictions, and communicate ideas and understanding. All models in science are based upon evidence. In engineering, models are used to analyze a system to see where and under what conditions flaws might develop. Engineering models can be used to test possible solutions, visualize and refine designs, communicate design features, and be used as prototypes for testing. When it comes to modeling, there really are 2 categories. Conceptual models can be expressed physically, mathematically, or both. Here is a short list of some conceptual models. There are a few key ideas of modeling to remember. Modeling can include any one step or all steps of the model cycle. Students can engage in the development of a model, then evaluate the model based upon evidence, and then revise their model to reflect any new information. Before using a microscope to view a plant cell, students can build a model of what they predict to see. Then students can view the plant cell through the microscope and update their model to reflect any new information. This idea can be extended to what happens to the same cell if you add a 10% saline solution or sugar solution. It is important to remember that models need to be consistent with and evaluated against empirical data. The NGSS makes it very clear that scientific models are not static, decorative projects. Constructing conceptual models for the sake of constructing a model does not allow students to advance their ideas and consider how the model works with respect to evidence. Here is a handy list of ways science teachers can increase the rigor of modeling activities so that the model can advance student learning. Use the model for student prediction or explanation of a system. Involve communication of ideas either orally or written from partners or small groups of students. Use the model as an assessment, either formative or summative, to check student understanding. Have the students discuss the limitations and precision of a model. Allow opportunities for students to interact with multiple types of model, including virtual simulations. Practice moving students through the 3 stages of a model cycle, including development, evaluation, and revision. Encourage students to use the model to answer questions about how and why. To conclude this video, please consider ways you will incorporate modeling into your instruction. What elements of NGSS will you choose to include to increase rigor? Please remember that modeling is not an easy task. Students will need many opportunities to engage with modeling to become successful with this science practice. Wishing you good luck on modeling in your classroom.